So we're going to be applying the concepts of graphing points to the distance and midpoint formulas. So what do you think midpoint means? The middle. Essentially the middle. The middle, though, when you think about it, can be a little bit vague. Like if you look at those three right now, Maria is sitting in the middle of Liz and Tyler, right? But for reasons that are probably fairly obvious, Maria's closer to Tyler than to Liz. Okay, and that's cute and all, but she's not exactly halfway between them, is she? Even still, she tried to cover it a little bit, but she's still not exactly halfway between them. Now, with the midpoint, we're looking at a point that's exactly halfway between two other points. Okay, now we have a concept of exactly halfway between two things already. If you took two tests and you got a 95 on one and an 85 on the other, what's your average? Yeah, 90. And 90 is exactly halfway between 95 and 85, right? Okay. So the midpoint is very closely related to the average. We're taking halfway between 2 points. So if we start with 2 points, let's pull up a graph here. And we'll start with any 2 points. Let's use -1, -2, and 3, -4. We want to find a point that's exactly halfway between them.
-1 and -2.
Sorry, -1, -2. Yep. And 3, -4. Okay with that? Did I graph them properly? Now we're looking for some point that's halfway between them. Now the cool thing about it is that the point that is halfway between them is exactly half the distance horizontally and half the distance vertically, right? So what's halfway between the two y values? What's halfway between -2 and -4? -3. All we do is we take -2 plus -4 and divide by 2, right? And what's halfway between the x values? What's halfway between -1 and +3? 1. So we take the average of the two x values. That gives us our midpoint, 1, -3. So our midpoint formula is very simple. You add your x's together and divide by 2. Okay, you're taking the average of your x's. And then you add your y's together and divide by 2. Take the average of your x's, the average of your y's. That's how you find your midpoint. Make sense? Now, let's look at the distance formula. So if we start with 2 points for our distance formula, let's use -1, 3 and 5, 2. -1, 3, yep, and 5, 2. We want to find the distance between the 2 points. Now, can we agree that the distance between the 2 points is equal to the length of that line segment?
Yeah.
Everybody okay with that? Yep. So what we can do is we can just create a triangle. If I draw a vertical line from one y value down to the other, and then a horizontal line from one x value over to the other, what kind of triangle have I created?
Right.
And what do I know I can use with the right triangle? Pythagorean theorem. Right? Yeah. And I'm looking for the length of my hypotenuse here. Well, what's the length of this leg on the side?
2.
1.
Oh,
and why is it 1? Well, because 3 minus 2 is 1. Right? Y value of 3 minus y value of 2 is 1. All right, what's the length of this side?
6.
6. And why is it 6? Because negative 1 minus 5 is negative 6, right? But distance is measured as positive. So the length of one side is 1. The length of the other side is 6, right? So if I square the length of one side, and I square the length of the other side, and I add them together, then I should get whatever my hypotenuse is, let's call it d for distance, squared. So d is going to be whatever I get when I take the square root of 3 minus 2 squared plus negative 1 minus 5 squared. So I've got 1 squared plus negative 6 squared. What do I get? Yeah?
37 squared. Right?
Right idea, wrongly stated.
Radical.
Radical 37. Okay? So 1 squared is 1. Negative 6 squared is 36. So I got 37 under the radical. So if I want an exact distance, there we go.
6.0.
Okay? Now, if they told me that these were the coordinates of two houses and I wanted to find the distance between them, then I would find a decimal answer. Because nobody wants to know that the distance from Tyler's house to Maria's house is radical 37 miles. Okay? That's kind of useless when you're driving a car. Okay? Unless your odometer, measures in radicals. Then it might be okay. Right. So in general, what we're doing is we're taking the distance by the square root of the difference of the x's. So x1 minus x2, that tells us the difference or the distance between the two x's, and the distance between the two y's. y1 minus y2.
This is x2 minus x1.
The good thing is it doesn't matter which order you go in.
Ah.
Okay? One will give you the opposite of the other. Like one might give you 5 and the other would give you negative 5. But when you square them, they're both going to be positive anyways.
Okay. And just because distance doesn't.
Right. Make sense?
Yeah.
Let's have a little bit of fun with this. You always get nervous when I say fun with math, right?
Just a little. Yeah.
I was telling the pre-calculus class how I was thinking about calculus this morning while I was getting ready for work. So here's 2 points, and they said that the distance between these 2 points is 5. And we need to find the value for b. So here's what we can do. We can plug this into our distance formula anyways, right? D equals the square root of x1 minus x2 squared plus y1 minus y2 squared. Well, we know d. What is it?
5.
All right. What's x1?
3.
3. What's x2?
7.
7. What's y1? Negative 5. And y2? B. So we're going to solve this equation. Now I'm going to combine 2 steps here. First of all, I don't really like that radical. Do you?
No.
How can I get rid of a radical? Yeah. Square both sides. So that's going to give me 5 squared, which is
25.
25. It's going to cancel my radical out on the right. That's one of the 2 steps I'm doing together. The other step is to simplify the parentheses.
Oh.
Okay? Or at least the first parentheses. So we know negative 4 squared is
16.
Alright, and we've got to FOIL this thing out. Negative 5 minus b times negative 5 minus b. What are we going to get? See, negative 5 times negative 5 is 25. Negative 5 times negative b is Negative 5 times negative b is positive 5b. Right? And I've got two of those, right? I've got negative 5 times negative b, and then negative b times negative 5. So I've got a total of 10 b's. Kind of dangerous, especially if you're allergic. And then negative b times negative b is
B squared.
negative times a negative is a positive. So if we move everything to one side, do a little bit of reordering, we'll have 0 equals b squared plus 10b plus 16. Everybody okay with that?
Mm-hmm.
Now, what does that factor into?
8 and 2.
8 and 2. So what are my values for b?
Negative 8, negative 2.
Negative 8 and negative 2. Two answers? Is that even possible? What do you think?
Can the distance be negative?
That's not a distance we were finding. That's just a value for a point.
Oh.
Okay, we already knew the distance. So the question is it possible to have two answers? Well, let's think about it. The point that we knew was 3, negative 5. Right?
Mm-hmm.
And we knew that our distance was 5 units. Right?
Yeah.
So if we think about all the points that are 5 units away, there's one here, there's one here, there's one here, there's one here. Is that it? Are those all the points that are 5 units away?
What do you know? No, you go down. Not at all.
How about maybe these are all the points that are 5 units away? That's kind of a poor circle, but you get the idea. Can I make it better? Probably not, but I'll try. That's a little better. Those are the points that are all 5 units away, right? Now we know that our other point had an x-coordinate of 7, right?
Okay.
So all the points that have an x-coordinate of 7 are on a line. Whoops, not that line. That's a bad line. That line, right? All of those points have an x value of 7, right? Well, what's the coordinates of this point right here? 7, negative 2. Look at that. There's a b. And what's the coordinates of that point right there?
7, negative 8.
7, negative 8.
So they both work.
So they both work. Now, sometimes you could have only one, because if you got that exact outer point of the circle, like this right here, well, then there's only one, right? But sometimes you'll have two. Do you think you... I think that's a pretty good way to check, right? Draw a quick picture. Now, do you think that you could find 3 points?
No.
Not with a single x value, right? Because if we're drawing that line with a single x value, we can only cross the circle once or twice, never 3 times.
But if it's a parabola, it can cross 4 times.
If it was a parabola, but that's for some Algebra 2 stuff. Okay? All right, any questions? All right.